Okay, so talking about Aeolus, which in terms of cloud technology is a relatively new project. It's still in a very developmental stage at the moment, but it's quite a fascinating project as well. So whereas I spoke with Overt in the context of open source cloud computing, competing against commercial closed products, for this presentation I'm going to talk about how you can take your virtualization environments and cloud environments to the next level using Aeolus. So a bit about Aeolus. It's an infrastructure service cloud management application. It has a few main functions. It provides hybrid cloud management, so you can connect your private clouds and virtualization environments such as Overt, Rev, VMware, and currently in development OpenStack. And it can also connect to public cloud providers such as Amazon EC2. You can create virtual machine images based upon user-defined templates and push them out to your cloud providers. And then create collections of virtual machine instances based on one or many pushed images. And then you can perform post-boot configuration on the virtual machines themselves and monitor their life cycles. So the current components of Aeolus include these 5 components. So this is the current components. So Delta Cloud API. Delta Cloud is basically the foundation for Aeolus. It uses a RESTful API that abstracts and manages resources from various cloud providers. So you've got support for, I can't remember exactly how many, but I mean, to give you an example, there's EC2, Overt, and Rev, vSphere, OpenStack, Rackspace, Eucalyptus, and others, remote hosting. Then you've got Oz, which builds base images from XML template descriptions. So the XML files define things such as the image OS type, installation media, where it's located, additional packages that you might need for your base images, and any additional commands or files to configure your image when you create it. Then you've got Image Factory, which builds images for your cloud providers. So Image Factory takes the base image from Oz and splits that up into several different several sub-images for various cloud providers, so provider-specific images. You've got Conductor, which is a high-level front end for Aeolus, so it uses Web UI to control the cloud providers, the hardware profiles, the clusters for them, and images and instances. And then you've got Audrey, which facilitates cross-cloud configurations and provides post-boot configuration. And currently in development, we've got Tim, which is a subcomponent within Conductor, which replaces our current image warehouse daemon. So it's a Rails engine responsible for cloud image management, and it allows clients to create and delete and upload images to multiple cloud providers. Tim builds on top of Image Factory's cloud abstraction layer and provides metadata, versioning, and access controls for images. Then you've got Heat, which is actually an OpenStack project, but we're looking at integrating it into Aeolus as well. So it provides a programmable interface to orchestrate multiple cloud applications, implementing well-known standards such as CloudFormations and Tosca. Then you've got Snap. This is still very early development, but it's an in-instance cloud configuration utility which allows the end user to take a snapshot of an instance running on a cloud and restore the instance running on another cloud provider. So currently Snap supports RPM-based, Debian-based, and Windows-based guests. And then you've got Winged Monkey, a self-service portal for non-administrative users, so that's in development as well. So a very simple process. So step 1, you add your cloud providers. So you might have an EC2 provider, you might have an Overt setup, you might have an OpenStack setup. And it's just a matter of entering access details to Aeolus there. Then you define templates for your images. So this is an example of a template definition file. So it's a little out of date, Fedora 16, but it sort of gives you an idea of what's involved here. So this basically is a Fedora 16 base image that automatically updates upon creation. Then you build and push your template, you build it into an image and then push it out to your cloud provider. And this is the UI for the build and push part for your images. Then you can create a deployment. So a deployment is essentially several instances together working as an application. So you might define, say, a simple web host and database server pair. So you're able to do that by, say, using base images, or say one image, or if you've got a specific image for one set of instances or another. So this is an example deployment file which contains 4 instances based upon 2 images. So as you can see here, the first 2 are based on the first image, and the last 2 are based on the second image. And this provides some information about the actual deployments. So to launch instances, as you saw here, it's just a matter of pressing that launch button. There's some defined information that you have to confirm there. And as I sort of spoke before with that template for deployables, it splits, or not splits, but it creates instances based upon original images, so you can create several different instances based upon the one image. And then you can provide post-boot configuration as well. So this is another deployment XML file, which shows 2 instances with cross-configuration there. So as you can see, it allows you to input parameters there, plus also take parameters from other hosts as well, from other instances. So you can take information, and you can also implement factor-based information from your host. So for example, your host IP or your host name. This is an example of a WordPress deployment being created. So basically as an application, you define, this here is the HTTP, so you define, say for example, launching a WordPress blog, you define your name and your username and password. And it also takes several details from the other instance, which is a MySQL host. So use cases, so to give you an example of 2 use cases where, say for example, an organization has a complex application deployment. In the past, you'd have to provide a series of instructions to configure, say, several number of services, whereas with Aeolus, you can, an organization can define all services within their image template files and the deployment template files and just hand them to whoever's interested. Another example, so application replication. So organizations can replicate applications from one provider to another for specific purposes. So an example I like to bring up is a university where peak times are always registration periods. So it creates an overload for the servers. And in my experience, I don't know if it's changed now, when you've got a heap of people during that early registration period, it basically, there's downtime, the service crash. What you can do is you can take that application, migrate it to, say for example, EC2, and have that running in in a public cloud, which frees up your private cloud architecture. So the benefits, it's provider agnostic. Oh. What's that? Okay, I'll speed this up. So benefits, provider agnostic. You've got one base image for multiple instances, quick deployment of instances. You've got app forms, basically those collection of instances together as a single entity. So basically you can say, I want to launch this application, I want to launch WordPress blog, a Drupal site, I want to launch Salesforce instance. You've got automatic configuration of instances as well because of the deployment files and the image files as well. It basically does that all automatically. There's REST API access as well for Aeolus. Future features include, you've got self-service, as I mentioned, Winged Monkey, and also a cost engine to calculate costs associated with public clouds. We've got the main website there. I'll put these slides up on the wiki. So there's pages on how to get it, how to use it. You can also compile from source. The source is on GitHub. Plus we've got an older version on the official Fedora repositories. So as I said, it acts as a central management unit for all cloud resources, regardless of provider, and provides you with a means to deploy complex applications quickly and efficiently. The best part is it's free and open source. So these are the things why I believe Aeolus is a great example of how open source software can take cloud infrastructure to the next level. Thank you very much for attending my presentations.